your command, sir.
Okay. Yeah, thank you very much. And good evening to everyone. I don't know if I can share my video so that you can.
Yes, you can share your screen now if you want to do that. It's okay. But if you want me to do that, it's okay as well.
Okay. So the video is shared. Yeah, thank you once again for giving me this opportunity. And I will encourage you to share the presentation while I talk from here.
Okay, sir.
Yeah, thank you.
Are you seeing it now, sir?
Yes, it's up now.
Okay, sir.
But maybe you can make it in presentation mode because okay, I think it's in... Okay, thank you once again. Yeah, I would like to speak to you not as a teacher or a lecturer, but more from an interactive point of view. And what I want to do in the next 30 minutes is to make all of you epidemiologists, to change your mindset, to begin to think like epidemiologists. Okay, by default, we are all epidemiologists to start with. It's something we learn from childhood. And epidemiologists can also be called epizootiologists, depending on who is speaking and from what perspective you are talking from. As I said, it's learned from childhood. For example, crossing the road is thinking like an epidemiologist. Saving money in banks is thinking like an epidemiologist. The choice of your profession, the better utilization of your allowances. When you are giving your allowances to go to school, why don't you finish spending everything at once? Why did you keep some? Weighing decision before you select the best option, and selecting a boyfriend or even a girlfriend and every other such consideration is what makes you an epidemiologist. Because what you are doing is to weigh the risk and take the better option. So that makes you an epidemiologist basically. And I know that many of you are students here, and so I won't bore you by giving you another set of lecture. I know you've done enough didactic classroom work, but I just want to set you thinking about who you really are and retune your mind to think and act right. So next slide. Next slide. Otherwise, I can also share from here if I'm permitted to share from here so that I can go at my pace.
Okay, no problem. I can just stop sharing my screen now.
Okay.
Yeah, you can do that now, sir.
Okay, thank you. I'm trying to pick the right slide. Okay. You can see my slide now? Okay.
Yes, we can see, sir. Thank you.
Okay, so thank you very much. So this is the leaflet that was shared. And the first instance, I was told I was an extraordinary veterinarian. This is the first time I'm hearing that. I never know I was extraordinary until the IBSA decided to call me that. And
you are absolutely extraordinary, sir. Super extraordinary.
Well,
you know that.
I'm here in the midst of all these people you see here are all my senior colleagues. So I will have considered them more of a giant compared to myself. But thank you for giving me that honor. But by default, all of us are also extraordinary. You know, every one of us, we are born champions. By the time you are born, it's one sperm cell out of the millions that won the race out of all of them, and that is why you are born. So by default, we are all champions and we can do excellently in our field. So coming to the basic definition of epidemiology, because it would be good to have a good background of that, is the study of disease in the population and of factors that determine occurrences over time. And you cannot have public health or animal health without epidemiology. The same thing, it's also called population medicine, is sometimes referred to as that. And it will also be good to know who is an epidemiologist or who is an epizootiologist. So it's a person that studies diseases within population. And that population can be human or animal population, and make inferences with which decisions are taken. And I have one of my lecturer who also called it, he said he's a professional who is biomedically literate, biostatistically numerate, and socio-economically cost conscious. So you cannot be an epidemiologist without having all this interaction. So you must always be thinking and have population thinking in mind. You must be able to understand how political, social, economic, anthropogenic, and scientific factors, how all these things and decisions interact together and how they intersect to exacerbate observed risk. For example, you should believe that nothing happened without a reason behind it. For example, if we pick the example of COVID-19, when coronavirus started, initially we all see it as the Chinese problem. Later, it moved to Italy. We see it as the Italian problem. Later, it moved to begin to spread in Europe. We see it as a European problem. But today, we see that it is our problem. And you see, I was part of an expert group that drew one of the first contingency plan for COVID. When we started, the first set of plan that was drawn and given to us, when we look at it, we saw it that the people who sit up to draw up that plan, they were mainly clinicians. So when they draw up this plan, it has a clinical point of view. Everything about it is how to take a patient, bring him to the clinic, and ensure that he is well taken care of in the clinic, and nothing more. So we look at it, we told them that no, this document is wrong. It cannot stand like this. We need to bring in the epidemiological point of view into the document, and we revise and we retune the whole thing to begin to see it from a wider point of view. So also, as part of the basics in epidemiology, is basically divided into 3 subdivisions. You have the descriptive epidemiology, the analytical, as well as the applied or interventional epidemiology. When you talk of descriptive epidemiology, that's where you have case reports, case series, you do prevalence study, you do incidence studies, and this will help you to identify patterns, quantities, and ultimately, it helps you to generate hypotheses. It's something you've observed in the society that you are now hypothesizing on. And then it can lead you to go into analytical epidemiology, where what you've observed before, you now begin to test those hypotheses. You begin to test the factors and determine outcome and evaluate the outcome, whether it actually speaks to what you've observed originally. And this can be done by setting up an experiment. It can be a control study, or it can be an observational study, now at a larger scale, like cohort study, case control studies, or whatever type of studies you are doing in the field. When you come to applied or interventional epidemiology, this one now focus on the application of the epidemiology that you've learned, all the basic principles you know. Now using it to deliver public good and to change policies so that you can influence actions. It delivers a source of reliable and actionable information from which decision makers and stakeholders can chart an effective course that will result in the promotion and protection of public health. I will give you a bit more example of this as we go along. But as an epidemiologist, your mind must always be working with 5 W's, which is what, who, where, when, and why, or how. So as an epidemiologist, these are questions that always come to your mind. Nothing just happened by chance for an epidemiologist. You always look at it from this different point of view. So the epidemiologist, who can be an epidemiologist? Basically, anyone can be an epidemiologist. Originally, I told you that for you, we are all born epidemiologists by default. And by every action and decision we take, we are epidemiologists. So, but in the field of epidemiology, you need some basic training where it can range from the field of medicine, vet medicine, public health, nursing, pharmacy, epidemiology, allied health sciences. You can also be a biologist from the field of biostatistics, mathematics, biology, geography, even health administration, social scientist. Anybody can be an epidemiologist. I used to narrow my mind previously until the day I saw somebody who is an excellent epidemiologist and is on the international board of some epidemiology journal. And I found out that his first degree was in heart. Then I begin to change my mind. I know that actually anybody can be an epidemiologist. It only needs the application of your mind. So what are the way the mind of an epidemiologist work? You need to have a strong understanding of statistical concepts. You cannot be a good epidemiologist if your mind cannot begin to conceive things and begin to rejiggle and turn things around. You also need a strong understanding of medical and biological processes. For example, now, if somebody asks you a question, why is it that we have abortion in a population? Your mind should immediately begin to think that when you talk of abortion, it cannot happen in male. It should only happen in female. When you talk of some processes, you begin to look at the logical reasons that goes with that thing. You must be able to have critical thinking skill and attention to details. Nothing just past an epidemiologist. And as we go along, you will see some of those examples here. And you must also have strong communication skill and computer skill. So what you've seen, what you've observed, you must be able to communicate it across. And people accept your logic. Okay, so I'll just start with this thinking. If you look at this picture down here, the picture of the houses and the market, the open market you see there. This is a picture we took when I was in Egypt. I went to Egypt while we were walking across the road. We saw this situation. And I just told them, oh, wait, let's take this picture. So we took the picture. As the general populace, they will look at this picture and say, oh, we have an open market to one side of the market, and that is what they see. But for an epidemiologist, you begin to see differently. So all these other descriptions you see above, I will just explain them briefly on what we see here. If you look at what we have here, it's the same thing as what you have in this picture. Now we are converting it to a three-dimensional space. Here in this market, this is an open market, which in front of it, they sell poultry on the road, chicken on the road, and this was during avian influenza. So what we are looking at is what are the things that influence the spread and transmission of avian influenza, especially among humans. So we do a three-dimensional space now. Now these are the building, this block you see, and this one on the lower end, this smaller block, is the infection. That's where infection is being generated and spreading. Now we begin to generate hypotheses and draw trees, decision tree. If you look up there, the decision tree is there. This decision tree says live bird market. Now we can have infected bird or non-infected bird. In live bird market, we can also have infected human or non-infected human. And we begin to continue with those hypotheses. Infected bird is either is detected or not detected. The same way, infected human is either is detected or not detected. If it's detected, it can be reported or it may not be reported. And if it's reported, the bird can be called. If it's not reported, the bird can be sold or can die or slaughtered. And then the infection can spread to other humans. And this infection cycle continue. So you see, from just merely looking at the simple market, we begin to draw the analysis, begin to draw the three-dimensional space, and see the direction and pattern of flow of hair. And then begin to see how this hair flow, how it's interrupted, and how infection can spread. Down here at the right-hand corner, this is how infection will spread. When that infectious material is generated from those poultry markets in front of the building, they can spread to all the vehicles that pass on this road, as well as into the house that is nearby. So let's go to the next slide. We were driving in Tanzania, and as we were driving, we saw this picture. I just told the driver, stop, we need to take this picture. Now we took this picture. As an epidemiologist, what do you see? That is the question that should come to your mind. This is not just ordinary dogs on the road with humans. This, we begin to see risk now. Risk of what? Risk of rabies, risk of echinococcosis, risk of everything that can be associated between dog and human. Now I can see human-animal environment interface just here in this picture. And that is why we take this picture. Indeed, this picture can begin to generate hypotheses. As you see this picture, you can design a whole PhD study based on this picture alone. And that is what you need to begin to see as an epidemiologist. You don't just let every situation pass you by. You look critically at the situation and begin to generate hypotheses around situation. For example, this woman you see right at the center here is at the risk of infection by rabies. For example, let's say one of these dogs just become aggressive and attack her. Before you know it, all these dogs will pounce on her and they begin to bite her. Some of them may introduce rabies to her. And also, all the people in the environment, they are also at the same risk. So you really want to know what an epidemiologist is? It's a person that carries the burden of everybody. You are always thinking of everybody's problem and how to solve these problems, and you are hardly thinking about your own problem, possibly. It's more or less a burden bearer. You bear so many people's burden, and you may forget yourself, even in the midst of bearing other people's burden. It's a person that is working not hard, but working smart. And epidemiologists don't just work hard. If you talk of working hard alone, then possibly the bricklayers and the carpenters and those who do artisanal job should be the one who are making the best decisions. But so you must be working smart. Everything you look at, you must think of a smart way to begin to address issues there. And you must not always make the last decision as an epidemiologist. The epidemiologists are influenciers. They are influencers. They influence decision makers. For example, if you come up with a decision and you now recommend to the policymaker, this is what we need to do to be able to do this. Yet, you are not the one making that decision, but it is based on your decision and your critical thinking that you are creating a creative thinking through which decisions are based. And so it means that you can be a great influence on the society. So if you are an epidemiologist and you cannot be changing people's mind from what you see this man doing to what you see this lady doing, then you may not be doing well yet. So if you call yourself an epidemiologist and after you finish what you are doing, people still ask you, so what? And so what is new? What have we gained? Then you need to rethink and check yourself again. You should be able to wow people and at the end of the day say, oh, really? So this is really here. We never know this. And that's what an epidemiologist should do. You should be able to add value to issues. You should be able to influence fields. You should be able to change people's mindset about even the data they have in their hand. And I will show you just two examples. This is one example. I encountered a student in the University of Pretoria in 2011. He did some excellent work on vaccinology. They used this thermostable vaccine. They tested it in some chickens, and they prepared a very great manuscript. And this manuscript was submitted the first time, the second time, the third time, the fourth time to different journals. And each time they submit this manuscript, the manuscript was rejected. I tell you, the manuscript was rejected not because there was no quality in the manuscript, but because the manuscript did not follow epidemiological principle. They work as a lab persons and as a vaccine testers, and they prepare the manuscript according to that. Then why are you preparing vaccine? Why are you using vaccines? Is it not to control disease in the society? So that is the thing that was lacking in the manuscript. So the candidate approached me and we revised the work now using epidemiological principles and epidemiological approach. And we resubmitted the paper to another journal. I tell you, in less than 2 months, you can see that red cycle I put. We resubmitted the paper April 22nd. By June 25 of the same year, the paper was accepted. And so the guy said, wow, so really this is what I've been suffering. So he began to have his thinking changed from this time forward. And he had gone ahead to publish many other publications after then. So this is the second example I want to show you. I met this student also, he's a student from Rwanda. I met him also in South Africa. He went into the archives of the animal hospital and draw out all the samples from 1995 to 2002. In total, he has 141 organ sample and environmental sample. And he wants to analyze them for Salmonella organism. So he did some excellent work. Indeed, he did bacteria isolation, DNA extraction, confirmation. He did virulotyping, pulse-field gel electrophoresis, and plasmid profiling. He did a lot of work. And by the time I look at the volume of work he do, I was asking him, really, are you planning to do a master's or you are planning to upgrade to a PhD? And then when he came to me, his supervisor sent him to me. When he came to me, he told me, say, okay, now I've done this work, and I told you, okay, explain what you've done to me and explain your results. He said, well, we did A, B, C, D, E, and at the end of the day, the thing was so percent positive by bacteria isolation, so percent positive by DNA extraction, so percent positive by virulotyping, and so percent positive by pulse field gel electrophoresis, and so percent positive by plasmid profiling. So I asked him, I said, so what? One, you need to understand the sample you are even bringing for me now. They are sample of between 1995 and 2002. And you are presenting this sample result to me in 2012. Most of those dogs who you are referring to are possibly dead or they are long gone. They are not available again. So what is the percentage positivity? What does it mean to me? It makes no meaning again, barely nothing. So I asked him, okay, where did you get this sample? You have the archives, you have the register. Did you collect data on age? No. Did you collect data on the sex or gender of the animal? No. What of the location where the sample come from? No. What of the class of owners? Maybe the rich, the poor, the middle class? No. So I told him, go back to those register, put this your positive, negative results down, and go and match them with all these other criteria. We need to have them. And he went to do that. So when he came back now with a more broader spreadsheet, I told him, oh, now let's begin to analyze your data. One, we did pairwise comparison of all the test methods that he used. We compared the PFGE to DNA, to bacteria isolation, to virulotyping. We got some results. We do now risk analysis based on the different criteria that he had done. We got the results. We compare environmental sample alone versus the organ sample based on those criteria. And we did all sorts of analysis now based on the same set of data that he produced. I can assure you he did not do a single extra lab work. He did not do a single extra work in the field or so. What we only did was to do a better data utilization of the same data that he had before. They ignored because he did not apply epidemiological principles. By the time we finished, he had 3 excellent manuscripts that we produced from the same set of data. And this changed his perspective. So now, if you look at this data now, this will be what a semi-epidemiologist may think of. Okay, we got this data, we test for antimicrobial, and these are the different level of antimicrobial resistance we found per year. So if you go to the next slide, for an epidemiologist, you may begin to think of it this way. If you look at it this way now, this easily makes meaning compared to the previous data you saw. What you are seeing here, immediately you begin to see a trend, some rising, some falling, and the different trend. So when you are dealing with your data, this will be easy to explain to, maybe you are dealing with a politician or the governor of a state, and you are now presenting those data in number to him. It doesn't make much meaning to him. But when you present it this way, it makes much better meaning to him, and you can influence his decision. So coming back to those 3 types of epidemiology I told you about, when you talk of descriptive epidemiology, these are some of the things you begin to see. Quantities, the trends, the percentages, the quantiles, the timelines, the trends. Those are things you see. For example, if you look at this milk, okay, we see that as the case of this bacteria is rising, the quantity of milk you are losing is also increasing. That will make meaning easily to a farmer. When you talk of analytical epidemiology, like when we talk of risk factor, risk analysis is an example. Like this one now, we're analyzing for E. coli bacteria in pig farming and how it influences. Immediately, you begin to see that The diarrhea in farm where you have diarrheic animal, you have to, the risk of E. coli infecting other animals that are not infected is higher. As the animal grow above 4 weeks of age, the risk of E. coli in them is higher. Why is this? Because now you are changing their environment. They stop drinking milk from their mother. They begin to eat solid food. So you change their gut flora. You change everything about them. They are stressed because they suddenly lose their mother and all those things. When you look at the years, you see that during the winter period, you tend to have a higher risk, and during the autumn. The same thing when you look at the months, you can see the months that present with higher risk. That is the month when rain begins to fall. So it shows that all these things are different factors that can influence risk. So when you talk about applied epidemiology or interventional epidemiology, this is an example. I will just pick the example of this Nigerian situation. This is a map we generated during the avian influenza in Nigeria. We first map all the major roads in Nigeria, all the major roads from the north down to the south. If you understand Nigeria context completely, you know that Lagos is where the money really is. And there is a lot of consumption of meat and things like that around Lagos, and Lagos has a huge population of people. And you know, a lot of local chicken, backyard chicken, household chicken are generated from the north. So when avian influenza started, it started first in Kaduna, and then before you know it, in Kano, Kaduna, Jos, and most of those other cities that are major in the north, they begin to have outbreaks. At the same time, they keep moving chicken from the north down to the south. And so the disease continue to spread from the north towards the south. And then if we do this definition by week count of cases, we found out that this progression just continue gradually from the north to the south. So it means that if you, as an applied epidemiologist, need to suggest to the government, you just tell them, put a barricade, cut off, maybe before River Niger bridge, just put a barrier so that animals are not moved again. You can easily stop the spread of the disease at that time. And these are some of the applications that we give to them. So, for example, if you look at this picture on your left-hand side, it's about a disease that was spreading centripetally. So all we need to do is this, using spatial scan statistics. You just put a wider cordon outside the spread area and just stop infection. You can put either military or police there. Don't let anybody move this situation outside this area. And immediately you stop the disease. So basically, an epidemiologist is somebody that changed this house you see on the left to the one on the right. If you look at the two houses, they are the same thing. The one is painted, one is decorated, has all the fitting in, one is just a blank house. I'm sure if you are to choose out of the two houses, you will choose that white one on the right. And that is what an epidemiologist do. So what is the role of an epidemiologist then? Basically, one, you oversee public and animal health program, including statistical analysis, planning, surveillance system, and public health improvement. You can investigate disease or parasite to determine risk factor. You can plan and direct studies. You can plan and administer and evaluate health standards. You can also provide expertise in designing, in management, and in evaluation of study protocol. You can also conduct research to develop methodologies. You can consult with and advise physicians, vets, and other professionals on their field. You can supervise professionals, both in technical and clerical area. You can identify and analyze public health issues, including foodborne issues. You can teach. At the same time, you can also help in standardization of drugs, dosages, immunization programs, and all sorts of things. So, specific role in public health, initially, the topic I was given was in animal health and food security. But there is no way you can have animal health without talking of public health too. So that's why I included public health. So you can play a role in disease surveillance, as we said, in outbreak investigation, in disease control, in observational or control studies. You can also influence through the use of application of hazard analysis, critical control points. You can help in environmental health assessment or environmental impact assessment, production standard setting, as well as in foodborne investigation. So in terms of food and nutritional security, I will go through that in the next few slides. because it's important. One, let's look at the year 2015 and going into year 2030, year 2050, the future of Africa. We found out that in terms of milk, by the year 2050, we will need at least 139% more milk than the current consumption in Kenya alone. In terms of beef consumption, we will need 230% more beef needed. In terms of goat consumption, almost 200%. In terms of poultry consumption, you need almost 250% more. And if you look at the African picture just on the right side, it also follows the similar trend. So it means that the future of farmers is really bright. Anybody who go into farming, going into the future, you have a bright future. And then the question would be, when you are doing all these things, let's look at the real scenario around it. For example, cattle, we come back to cattle. Cattle significantly impact on our current resources. I'm sure you and I know that there are a lot of conflicts between cattle herders, practically the Fulani herdsmen, and other pastoralists all over Africa. They do have a lot of conflict with arable farmers and with communities. Why are they having this why are they having this crisis? One, you know that cattle utilize a lot of land space in terms of grazing, in terms of moving around, in terms of a lot of movement. And you know that as human population grow, the land space will become smaller and smaller because you have less land to utilize. In terms of income, currently cattle generate almost about 50% of household income for those who are engaged in it. And it contributes to food and nutritional security. So per capita consumption of cattle is about 11.3 kilograms per annum. And we take about 121 liters of milk per year, averagely in Africa. But in terms of public health, we know cattle can also negatively impact public health. For example, zoonotic disease. You talk of things like brucellosis, you talk of salmonellosis, you talk of E. coli, you talk of a lot of infection we can pick. You talk of bovine tuberculosis. And this animal disease alone that we get from cattle, it can cost us up to, for example, 4.8 billion US. What of antibiotics? You know, a lot of antibiotics are used in the dairy industry. So it means cattle can also influence our society, our system by giving us antimicrobial resistance. So then it means that you really have challenges even as much as you have benefit with this animal. So what are the challenges that we can briefly identify? One, high density of animal and human in the peri-urban area. If you look at Abuja, I've seen pictures around Abuja, around Nairobi, you see this peri-urban farming. You see animal moving around the cities. It's happening in most of the societies around Africa. So, and this will continue going into the future. We have weak public and animal health services. We know that the public health and animal health services in most of the African countries are not up to what we want. We have weak enforcement of rules and regulation. Even where you have rules and regulation, are they adhered to? Are they implemented and enforced? We have negative impact on and of livestock on the environment. For example, arable farmers, these cattle just enter their farm and begin to eat their crops, and then created a lot of problems. High prevalence of foodborne diseases. We all know these are available in our environment. We have a lot of counterfeiting of veterinary drugs and also human health drugs. And we also have livestock contribution to AMR due to inappropriate use of antimicrobials by farmers. So the question is, do we need an epidemiologist to help in planning the future? Your guess is as good as mine. If you look at the pictures to the right hand, this is the picture, or this is the scenario that we have for 2015 in terms of contribution of each of the different sectors of the cattle and what it's likely to look like in 2050. For example, if you look at the pastoral system, it's about 43% of the total animal population in Africa now. By 2050, I can tell you it will shrink to less than 25% because there will not be enough land again to move around. If you look at things like the ranching will increase by 2050. If you look at intensive dairy production, it will also increase by 2050 because there will be less available space for animals to move around. So agropastoralism also will shrink a bit, and then those activities that need less land spaces will increase. And so to think of the epidemiologic principle around this, you need an epidemiologist, definitely. So if we also look at the future and imagine and reimagine infectious disease, indeed, this picture, we drew it in 2015. That if you look at this picture on your right-hand side, and you look at the situation of coronavirus currently, just look at the picture very well. You can be assured that this is what is happening now. For example, we take EID outbreak, that's emerging infectious disease outbreak. Let's analyze this. Human affected. Coronavirus now had affected human. We have death. We have some people are orphaned already. We have closure of business. You have reduced government income. You have unemployment increasing. You have sluggish economy. In terms of animals are affected. Some died, some reduced productivity. Indeed, some have productions, but they cannot even sell their product. So production reduction will happen. Trade ban is happening. You can't move animal from one place to the other. Demand decrease, and fear of contagion is there. So because of this, so we just look at the magnitude of the future livestock in terms of livelihood, environment, and public health challenge. They will vary differently by the year 2050. As we go into the future, there will be a lot of changes. So the role of epidemiologists will become more and more and more. Otherwise, if you don't include epidemiology in terms of planning and intervention for the future, you may have collapsed economy and collapsing state. You may have social unrest and political turmoil. So the increased risk of outbreak of emerging and re-emerging infectious disease will continue to be there. And there will be ongoing rapid urbanization. So the question again is that, do we need an epidemiologist in planning the future? I believe the answer is yes. So I would like to stop there so that I can allow you room to ask questions. And I want to thank you for giving me this opportunity. And I hope I've been able to make an epidemiologist of some of you. Thank you.
You're very, very welcome, sir. And yes, to that question as well, you've been able to make an epidemiologist of some of us. Like me personally, I have a general interest in public health, but with this lecture, honestly speaking, I'm seriously considering a bias for epidemiology. Thank you very much, sir. I think when I started, we called you an extraordinary vet, and I think everybody attending this lecture now is a living witness that yes, you're truly an extraordinary vet. So before I hand over to you, Gloria, I'd like to thank you very, very much. As a summary, we've been motivated to go into epidemiology, not based on the scientific inclination, but on the impact it will have on the society, on our communities, and how it can help us secure a better future when it comes to food security and economy. So, and thank you very much, sir. You did not just do the epidemiology thing, you also inspired us to be critical thinkers. Because from this lecture, I personally, I picked so many things that has actually inspired me to be a critical thinking person. For example, the picture you showed on when you do a research and the outcome is up and everything, if people will still ask you, so what, then it doesn't make any sense. So I think the budding researchers amongst us will now think of ways to present their researches and everything in such a way that it will have a translation that affects the community positively. So thank you very much, sir. We really appreciate it. So is Gloria here? Can she unmute herself to give a vote of thanks? Or before then, would like to take questions in the chat box. You'll be allowed to type your questions in the chat box. Nobody is to unmute himself or herself. We want to maintain orderliness. So when you type your question, I will read them out for our professor to answer. So is there anybody with a question for our extraordinary vet for today? Okay. So I see some people are typing. Just a minute, sir. We'll be having questions very soon.
Yeah, that's okay.
Okay. Well, this is from another extraordinary vet, Dr. Shields Chamsuddin. Thank you for attending our lecture. He said, what is the connection between epidemiology and industry? And to what extent are epidemiologists impactful on private sector and the industry? So the last question is, can an epidemiologist work privately? So let me take the questions again. The first one was, what is the connection between epidemiology and industry? The second one, to what extent are epidemiologists impactful on private sector and industry? And the last one is, can an epidemiologist work privately?
Yeah. Okay. So you want me to answer this, or you want more questions before I answer? I
Yes,
can
you
see the.
can answer this. So by the time
Okay.
you finish with this, we'll get more questions that we can.
Okay. Thank you. What is the connection between epidemiology and industry? I can assure you that epidemiology influences the industry, and most of the industry actually look for and seek good epidemiologists. One thing you need to know is that if you want to be an epidemiologist, be ready to be the best in your industry. For example, I was lecturing in the University of Pretoria. I was invited by FAO to come and head the team in Kenya. And I headed the team in Kenya. Then 2 years, they moved me to Tanzania to head the team. So as an epidemiologist, if you go back to those roles of epidemiology I mentioned, you actually lead a team. You can coordinate things. For example, when you are working with a team, a lot of them may not see the contribution they are making. But you as an epidemiologist should be able to bring together all those different thinking and make sense out of data. For example, we went to the field in Motion, part of Tanzania, and we went to implement rabies vaccination in response to an outbreak of rabies in a community. Yes, we did the rabies vaccination and we helped the community to stop rabies transmission, and it ended there. That is where most of the people or the clinicians sees it. I said, no, it does not end there. One, we need to write those reports and bring out the concept out of it. So from those reports, we wrote and we published 2 papers on the ecology and epidemiology of rabies in that community. We also wrote on the economic impact of rabies in that community. And I tell you, the write-up we made was even published by the White House in US. They reported it as part of the report of the intervention US government supported last year from the White House. So that shows what you can do in the industry. For example, in the different industries, you look at the pharmaceutical industry, the poultry industry, the animal health industry, every industry, they all need epidemiologists, and they all seek out good epidemiologists to be included in their work, or they put you on retainership. I know a lot of epidemiologists that are on retainership. I was interacting with an epidemiologist recently, and I asked him, "Oh, why did you leave London and move to Hong Kong?" He said, well, because now my children are growing and I need more money. And now in Hong Kong, they were offering me 3 times what I was earning in London. So you can imagine what it means he was earning now, if he's earning 3 times. So that's one thing. So as an epidemiologist, you are actually needed in almost every sector of the society, even in terms of government. I know an epidemiologist that worked for the Canadian government, and he was given a citizenship there. He's a Nigerian, but he works with the Canadian government, and I've interfaced with him before, and he has a residency and citizenship in Canada. So the second question is, can epidemiologists work privately? Definitely, yes. I've known a lot of epidemiologists who just set up their own consultancy firms, and they organize and they get a lot of jobs. And if you are a good epidemiologist in your field, you will even see many industry, many companies, they will come and meet you and say, please, can you help us do this? Or they bring a lot of data for you and say, please, can you help us analyze this data? I've known, for example, if you check Epics Analytics and so many other companies online, they are epidemiology group. They set themselves up and they move out of doing government job, or they move out of doing university job, and they sort of their private environment for work, and they are doing excellently well.
Thank you very, very much, sir. Okay. I wanted to say I am with the extraordinary vet that asked that question and is actually convenient with the answers, but he also typed himself that excellent responses. Thank you very much, sir. That was so much appreciated. Another question that popped up is can a parasitologist become an epidemiologist also? Can a parasitologist become an epidemiologist also?
Okay. Yes. To answer that question, I will take you back to my presentation. When I was presenting, actually, there is something I did not mention in the presentation. By definition and by training, I'm a vet. And when I was going for my master's, I was going for a master's in virology, poultry virology. And I went to Pretoria with that mindset to work on African swine fever or Newcastle disease, which are poultry disease or pig diseases. But when I got there, my sample was delaying in coming from Nigeria. The sample was to be sent to me from Nigeria. And one thing an epidemiologist do is that you begin to apply your mind. You see, in every challenge, you begin to look for opportunity. While my sample was delaying in coming, I begin to think, so do I just sit down and keep looking? Say, okay, I need to work on avian influenza now. What of the economic cost of avian influenza? What of the control and no control, which was a raging debate then? Do we control by vaccination or no vaccination? What of the vaccination, no vaccination approach to avian influenza? I begin to think of so many areas by which I can work around the real core virology I came to do in Pretoria. So at the end of the day, my sample delayed for about 7 months before it finally arrived. By those 7 months that the sample arrived, I tell you I've worked on another 5 papers. And that was one of the things that began to tune my mind to epidemiology and to tune it away from the core virology. Because from the core virology, I actually published a single paper, which is molecular virology of the disease. But I published a lot more paper from the epidemiological point of view. So as a parasitologist, one thing you need to begin to think of is that how do I apply epidemiological principle to my parasitology? So it's not just enough to collect sample and say, oh, I found so percent of this parasite or that parasite. What is the implication of that on the society, on human society, on animal society? Is there a linkage between the different subpopulation? Maybe the rich, do they have it more than the poor? Is it equal between the slum area and the modernized area? Is it the same between the different cities and all those things? So that those are epidemiologic principles. And so you can definitely apply it.
Okay, thank you very much. That was another excellent answer. Thank you so much. I'm really enjoying this and I don't want it to end. But then we'll take the last question for the day because of time. If not for them, I'd have loved to host the professor for longer than this. So the last question we'll be taking is, it seems like skills like data analysis and science is required, and these are not being taught effectively in vet schools. So what can be done to go around this? The person is asking the things that can be done by vet students, I believe, to work around the issue of data science and data analysis, big data and all of that. As an epidemiologist, we all know you're going to need statistical tools and all of that. And he's saying these are not being taught effectively in vet schools, according to the person asking the question. So what can vet students do to come up with this? That will be the last question, sir.
Okay. Yeah, thank you for that question. And it's actually a right question to ask at this forum. You know, one of the things I found challenging in Africa particularly is the fact that we don't have enough mentorship. You know, the problem is that we don't have enough mentor, and then it means that a lot of us have to grow through self-learning. For example, one of the ways by which I began to do more of statistics was initially I used to work with a statistician. When I give him the data, yes, he do a lot of excellent statistics, then he brings the data back to me and the outcome that he had produced. But he is only looking at the data from the statistical point of view as a statistician. He does not even know how to interpret the data. For example, he can begin to analyze for pregnancy in men. He can begin to analyze for things that does not make logic in biology. So when they presented some of those data to me, I asked him, oh, yes, this analysis you've done is great, but this is not really what I needed, because I have this data, but it does not make logical sense when we are talking about biology. So I begin to teach myself too. And gradually I improved. And these days, you know, the advantage we have is that we even have a lot of open online source epidemiologic tool. You have a lot of data tool that you can use. And it's also important to climb on the shoulder of giants. I tell you, all of us need to climb on the shoulder of giants. Even though you may think that I think I've arrived, there are some of my colleagues, for example, I personally I have a group of people who are in US, in Europe, everywhere, doing and specializing in different areas of epidemiology. If I need to do maybe spatial scan statistics, or I need to do quantitative epidemiology and I don't have the tool on my system, I know who I can call and I can say, oh, man, by tomorrow I need this result. Get it done for me. And I'm sure I'm going to have that result. You need to begin to build a pool. Collaboration is important. Building a pool of researchers is important. Looking for who to serve as your mentor is important. Looking for who you can follow. For example, when I started, you know, like up to now, I have about 140 something people. But when I started, I have a guy who was in one of the universities in US then, who I was looking up to. I told him, I said, if you can do this, now I want to do this. By the time we were talking, this guy had over 700 publications and is one of the very highly cited researchers. I told him, I said, oh, you are one of my model and I'm going to pattern my this thing after you. And that is my target. So if I think I've had 100 people or 140 or 150 people, to me, I've not achieved anything because my goal, I've not reached there. And so you also need to begin to cast your mind that way. Look for a mentor. It will be very important for you. Begin to build collaboration. For example, your master's opportunity, your PhD opportunity is an opportunity for you to build collaboration. It's not just a matter of going to school to do another didactic study. You are not going to classroom again. When you are doing your master's, you are supposed to be learning principles of being a researcher. When you are doing your PhD, you're actually learning to become a lead researcher, because immediately after PhD, you are supposed to be able to lead and set up research. So if after you finish your PhD, you cannot lead a research, you cannot put together a research team and get them to work and get things for you. You cannot manage people, manage resources, manage data. You failed as a PhD person, even if you come up with an excellent result. So these are some of the value that you need to add to yourself while in school, and also look for people who you can grow with. That would be my answer.
Thank you very, very much, sir. That was a very excellent answer. And I believe you've answered the question even beyond the person that asked the question's expectation. Thank you so much. Really enjoyed this session so much. It just came to my attention that we have a lecturer, at least us, Dr. Bukola Adenbi from the Department of Veterinary Pharmacology, FINAP. Thank you very much, Mar, for attending. We're really glad to have you amongst us. So finally, I'll be handing over to Gloria to give a vote of thanks to Professor Folorunsho for this honor, this privilege of attending and presenting an excellent presentation on epidemiology and security. Thank you so much. Gloria, can you come up? Anna, you should unmute Gloria. I sent you her name. Anna, can you unmute? Okay, I think Gloria is
Sorry,
out
I'm looking
first.
for her.
Lavina? Okay, so thank you very much, sir. We're very, very glad to have you. And subsequently, we hope you will honor our invitation for lectures like this. And you will also serve as a mentor to many of us, like someone like me that is interested in public health and is now having bias for epidemiology. I think in the future, I may need to contact you, and I hope that you respond. So thank you very, very much. We really appreciate. We really love the lecture so much. So lastly, I would like to secure permission to share your slides with participants because some of them are actually asking us to share with them, and I can't do that without your permission. So humbly
Yes,
seeking.
you are free to share the slide. I'm publicly funded, so it's not a personal material.
Okay, okay, thank you very much, sir. So that will be the end of today's session. I hope, I do not hope, I know that you've enjoyed it. You'll come back tomorrow. So I'll be glad to see everyone on board tomorrow again. Thank you so much. My name is Dauda Onawala. I remember I didn't mention that at the beginning. Thank you all.